Okay, we're talking about part two of stoichiometry, which we're going to focus in on the limiting reactant, the excess reactant, and then we're going to learn about percent yield in a following video for it. So this is part two of stoichiometry because we're still building off that concept of stoichiometry, aka our big idea that quantities of all reactants are not always completely consumed. And that's how we have our two terms for today. We'll have a limiting reactant that limits it, and then we'll have an excess one for it too. Now, we do need a calculator for today, handy and ready to go. So remember, the whole idea of stoichiometry is to predict how much you'll make for it. So when we're looking at reaction stoichiometry, we're given our reactants and then we're going to be predicting how much product we can make. Now, sometimes we don't make all of it, so that's a bummer, but it's one of those things that just happens in lab for it. So we're going to classify it into our two types. Our first one is our limiting reactant. And if something is limited addition, you'll notice that there's not much of it there. Or if we have something that limits us from doing it, we'll see that it stops us from going someplace like a barrier. So the one that limits or stops the reaction from making any more product is known as our limiting reactant, and a lot of times we'll just call it LR for it. Now, this is also known as our theoretical yield, which is our maximum amount of quantity for our product. Now, we'll use the theoretical yield in another video when we talk about percent yield for it. So the other reactant, so remember we have two reactants in these problems, is known as our excess. So we're going to write X and then S. So our excess reactant is the one that there's extra of. It is not completely consumed for this reaction. And what that means is that if I have my reactant 1 and I have my reactant 2, one of them is going to make a small number, aka a lower number, and that's going to be known as our limiter or our LR reactant. And then the other reactant might make a larger or a bigger number, and that's going to be known as our excess. And how we figure this out is that we're going to use our gram to gram conversion for it. So if we're looking at it visually, we can see if we have 8 car bodies and we have 48 tires. So for each of these cars, we're going to need 4 of them. So we would see that I have 4 here. I'm going to see I have 4 here, 4 here, 4 here, each group of 4, 4 as I keep going through, and we're going to see that if each car needs 4, we'll put together, okay, this car with this one, this car with this one, and so forth for it. So we would see that our car bodies what actually run out first for it. So our car bodies would be our limiter. They limit how many cars with full 4 tires we could make, and that means our tires would be our excess because we have extra over. So we could make 8 complete cars, and then we would have 16 tires in excess. So that's just it looking at it visually for making a car for it. But we're not going to be talking about making a car for it in chemistry. We're going to be using it mathematically, and this is why we needed our calculator for today. So for these problems, you'll need to find out how much of your product is made from both of your reactants. So the lower amount out of the two reactants would be your limiting, or we sometimes call it our limiter. We'll see that the higher amount would be our excess reactant, and we can write it as XS, limiter as LR for it. And then we'll see that you have to convert to the same product to figure out which one's lower and which one's excess. If you take the reactant and you go to different products, you wouldn't be able to observe which one is lower and which one is higher for it. Now, the chemical reaction, whenever we're doing stoichiometry, has to be balanced for it. So please keep that in mind as you're going through, that these chemical reactions need to be balanced. So let's start our first one. Example number 1, it says 1N2 plus 3H2 yields 2NH3. So it says if you begin with 15 grams of both reactants, so 15 grams of this one, 15 grams of that one, which one would be the limiting reactant, aka the lower, and which one would be the excess reactant, aka the higher? So step one in these problems, you're going to have to convert grams of R to grams of the same P. Now this is pretty easy because there's just one P for it. So notice that we have our 2 grams to grams already set up, and now we're going to go from N2 to NH3, and then we're going to go from H2 to NH3. So if we take a look, we're going to have our 15 grams of N2 first. Now remember, when we're doing a grams to grams, whenever we write G, we need to have 1 with it. Then we need grams of N2 to cancel out, so I need to go to the periodic table. And I see on my periodic table that nitrogen is 14.007. Now, typically we round it to 14.01, but if you're feeling lazy today, you could just leave it as 28. I'm going to write 28.02 here. Now, because I wrote grams, I need 1 mole on top. And that's like a mole to gram conversion that we did in the beginning of the year. Now, our third step is where we're going to transition from our N2 to our NH3. So we'll notice we have 1 mole of N2 on the bottom, and we'll have 2 moles of NH3 on top. So we'll need 1 mole of NH3 on the bottom, and then we're going to have to find how many grams are in NH3. Now, the great thing about these limiting and excess, your last step will be identical for both reactants, because remember, we're going to the same product for it. So if I add up 1N, that's 14.01, and we look at hydrogen is 1.01, and 3 of those would be 3.03, we'll see we get 17.04 for our last part. Now, make sure that your units cancel out for each one. Awesome. And then this is where we need our calculator for finding our answer. So we're going to do the top first. We have 15 times 2 times 17.04, and I have 511.2 for my top. The bottom's pretty easy. We have 1 times 28.02 times 1 times 1. So right now, I'm going to put that 511.2, and I'm going to divide it by 28.02. Now we get a long decimal, so 18.2441135. So go back to 15. How many sig figs are in 15? 2. So we're going to count over 1, 2. Will 2 round it up? Nope. So we're going to have 18 grams of NH3. Now, we can't tell if this is the limiting or excess yet, because now we have to do the other reactant, H2 to NH3. So I'm going to do it in green down below. We still start with 15 grams, but now we're going to write H2. We need to have grams of H2 on the bottom, so 1H is 1.01, so 2 H's would be 2.02. We wrote grams, so we need moles there, so 1 mole of H2. Now we're at our mole ratio, so we find that H is going to be 3 moles of H2, and we're still going to that same product, so we have 2 moles of NH3. Now, like I said before, our last step is going to be the same because we're converting to the same product. So we're going to have 17.04 grams of NH3 here, and we're going to have 1 mole of NH3 on the bottom. So make sure that your units cancel out. Gram of H2, mole of H2, mole of H2, mole of NH3, mole of NH3. And then we're going to multiply the top and get our number. So 15 times 1 times 2 times 17.04. And notice that we actually have the same exact number. And that makes sense because we still had the same amount of given. We still had 2 moles from our balanced chemical equation, and the molar mass was the same. So we have 511.2, but the bottom's going to be a bit different. We now have 1 times 2.02 times 3 times 1. So 2.02 times 3, we're going to get 6.06. So right now in our calculator, we're going to do 511.2 divided by 6.06. And we see we get 84.356436564. Okay, go back to your given. How many sig figs are in 15? That's 2. So we need to round it to 2. So 1, 2. Will 3 round it up? Nope. So for H2, we would make 84 grams of NH3. Okay, so now this is the time that we're going to decide what is our limiter and what's our excess. So we have N2 can make 18 grams of our product, whereas H2 can make 84. So remember that the lower is going to be your limiter. So which one's lower, 18 or 84? Okay, I hope you yelled at your screen that it's 18. So our limiter would be N2 and our excess would be H2. So N2, nitrogen would stop the reaction once 18 grams of NH3 was made, and then we would have an excess of H2 gas as our other reactant left over from our reaction. So what does this mean? It just means that 15 grams of your first reactant, N2, can make 18 of them, and then 15 grams of H2 can make 84. So we would see that the lower product go back to N2 is going to be your limiter, and the higher product go back to your H2 is going to be your excess for it. So like we said before, we can call that limiter as our theoretical yield. So theoretically, we'd be able to make 18 grams of NH3. So thanks for watching the basics of limiting and excess reactants.